And we're back, and it's COMP305 in the winter 2016 semester, and it's week 3, lesson 3, part 3. And last day we really kind of worked on. I'm still working with this last project we're working on, COMP305, and it's winter 2016 mail pilot. Again, for those people who are just joining, you can find it on GitHub. If you go to Centennial College, you'll see that there is a COMP305 W2016 mail pilot project on GitHub. That's the one I'm working with. Okay, so and to make this work, you'd have to download this one and open it up with the latest version of Unity. If you're using Unity 4.x, you're going to have to rebuild your project because 4.x projects are not compatible with this one. Not backwards compatible. There's some breaking changes, like I said last time, in 4 comes to 5, 5 back to 4. It's not compatible from a scene perspective, so your scenes won't work. All right, so this is what we got so far. So when we play the game so far, we've got this the plane, and I'll see it here it is, and I can move it around with my keys, with my arrow keys and my A and D keys. So you can move them around, right? That's what you can do. Notice that no matter what I do with the mouse here, it doesn't really matter because there's no mouse input. It's just keyboard input right now. Okay, so we see the island and it's coming down. What I want to do is I want to create the next object, which is the final object for us, which is our clouds, right? Now the clouds, they're a little different than the island in that we're going to create a cloud object, but I want to make more than one cloud. So this is going to be the time we talk about prefabs. So my cloud is actually going to be a bunch of these hazards. And what we're going to do is we're going to regenerate them. We're going to create them or instantiate these prefabs. And we're going to reset them like before. I'm going to have a number of different clouds that we're going to instantiate and use. But they're just going to reset. We're going to instantiate them once, these clouds, and then we're going to reset them, just like we do the island. So it's going to be very similar code to the island. And I'm going to show you again. There's an opportunity for us to use a class to do some inheritance, so we can, instead of copying the code like we're going to do, there might be an opportunity for us to make a kind of almost like a super class where we can use to inherit from the other classes. For now, though, like I said, let's keep it simple and let's make it work, and then afterwards we'll fix it up. All right, because again, there's lots of stuff to learn here. All right, so we have our island. Remember we did last time. We have our scripts, and we also have our sprites. Our sprites, again, are just image files that are here inside of our sprites folder. And if I click on my cloud, right, this is a preview of what it would look like. Again, I want to change my pixels per unit from 100 to 1. So it's like 1 to 1, pixel perfect kind of game that's what we're making. Again, in some cases, you may not want to make a pixel perfect game because you may want to port this over to a specific device or different devices. And if it's a flexible number here that we use instead of a 1 to 1, instead of scaling up, you can be more responsive. Well, that's a topic for another day. Okay, so filter mode, we're going to change this to point like we normally do. So those are the two changes we have to make to our sprite objects to make it pixel perfect or 1 to 1. Cool, so we've done that. I'm going to click apply, which is going to change our ratio. So now if you notice our plane, if I click on my plane object, and my plane sprite, notice on the bottom it says my size on the bottom here is 65 by 65. So that's the size of my object, my size of my sprite. For my ocean, it's pretty large. It's 640 by 1440, and that's why there's 3 panels of ocean that I'm going to be cycling through, right? For my island, it's 62 by 63, almost the same size as my plane. You can actually see that, how big it is. My clouds, though, are something else. They're 226 by 178, so they're quite big. And that's in pixels again, quite big compared to my plane. So they'll be like this big, right? All right, so the first thing, we know I need to make more than one cloud. Yes?
In the picture here, when you see the cloud, there is a background, right?
There's no background. If you see a background, that's bad. That means it should be, the background that you see here, right here, it should be transparent. Because this is a ping image that you're seeing. So if you see a background, that's some setting you haven't set up here. Right? So let me continue here. So again, if you notice, from a texture type, it's Sprite, 2D, and UI. That's the texture type. That might be the one that you want. You can also choose other ones. But for now, let's leave it as is. So this is just a preview of what it looks like, this cloud, right? That's all it is. Okay, so what I want to do is I want to pull it in just like normal. So there's a couple of strategies we can use here. I can pull in this cloud, make a prefab, almost like what a prefab is. Think of it as like a blueprint, right? And I can store it in my prefabs folder. So first I pull it in and configure it just like I do ocean, plane, and island. And once it's configured, I pull it back into my assets, into my prefab folder. And when I do, it'll turn blue. When it turns blue, it means, hey, now you can copy this prefab over and over again. And so I can pull in 1, 2, 3, 4 clouds, however many clouds I want. Okay, I can do that. And they're all going to behave separately, like separate objects. Okay, I could do that. But that's really inefficient. So what we want to do is we want to create something else, I'm telling you ahead of time, called a cloud controller. But the cloud controller, I mean, that's just for one cloud, right? I want to make a game controller that kind of controls my game itself. So it tells the game when it starts how many clouds I have that start off, what happens to them, how do they when I instantiate and all that kind of stuff. And maybe my game controller can also take care of things like my score, which I need to take care of, and other things I can store in that game controller. It's almost going to be like we're going to put it in an empty game object. We're not going to actually instantiate an object that it's going to be attached to. So an empty game object has no physical shape. It's part of our scene, but think of it as a container object that we can store other scripts inside of. That's what we're going to use it for, right? And that's what we use this empty game object for. So we're going to do that. I'm just giving a kind of a summary of what we're going to do. Now again, first we're going to have to create a cloud object. Notice that again, just as a recap, our ocean is at order in layer 0, our island is in layer 1, and our plane is in layer 2. Those are the three things. So obviously our cloud's going to go above our plane, right? And our plane's going to be under the cloud. That's how I want it to be done. Now you could argue that it could be above the clouds too, right? But if that was true, then the plane shouldn't really ever collide with the clouds and it would be out of danger, right? We want the plane to be in danger, so it's going to be under the clouds where the lightning is going to kind of flash onto it, theoretically, right? Because showing the lightning is going to be more challenging. So we're going to make it in above the plane, which means order and layer is going to have to be 3. So these are all considerations. I'm going to pull it in. So I'm going to take the cloud object and pull it into my scene. Again, we're going to create it, and there's what the cloud would look like in terms of how big it is, right? I'm going to bring this I'm going to just make it a little bit closer so you can see it all, guys and girls. All right, so big cloud. All right, now obviously I don't want to start the cloud here. It'd be starting off just like we do the island. It would start off screen somewhere, right? Now it doesn't matter where I put it because I'm going to use my code to reset it. All right. So where do I want it? That's the first thing. Notice how again I have a sprite render and everything else. One thing I'd like to do, like I always did, is rename the cloud with a capital C because that's just my standard, if you will, my convention I've been using. Cloud with a capital C, island with a capital I, plane with a capital P. Right? Cool. Cloud with a capital I, cloud with a capital C. All right, so what I want to do is take this and use the manipulator arm here, the widget here, to the gizmo, to kind of pull this cloud outside. So I want to start it off screen around there, right? Now it's going to have the same property as the island in that it's going to start off screen here, right? And notice that my off screen, for me, it looks like around 330. It might be a little bit different for you, but for me, it looks like my optimal place is around 330 pixels on the Y, right? Okay, let's try again. If I move it, we should probably have above the same. And again, I'm going to kind of pull it underneath here and focus in. And we can see that as I come closer, and if I want to touch the top of my cloud to the scene, it looks like around the same. So let's say 330 in that range, minus 330 and 330. So that's a difference. The only difference between my cloud and my island is the location, 330 and 330 right now. Okay, take a look at this. My order and layer, see how the island is over the cloud? That's just weird, right? So we're going to make the order and layer 3, like we said. Now we notice now that the cloud is over the island, and in fact, it goes over the plane. You can actually preview them right here, right? Also the plane, if you take the plane, if you move it over the island, see how that the order and layer looks like this, see? So 1, 2, 3, 4, right? So 0, 1, 2, 3 is what it is, right? So I just wanted to show you that so you see that. So minus 330 and 330 is where it's going to be. Just to position everything on screen, I'm going to position this cloud so it's up here somewhere at 330. Okay? Not because it's important, because remember, it's just in the scene. We're going to use our code to reset it where it's supposed to be anyway. Okay? All right, well, that's pretty simple. That's first piece is done. Second piece is just like we did before. So we're going to go into our scripts, and we have our island and ocean and plane. We're going to make a new one. We're going to create a new C# script, and we're going to call it Cloud Controller, right? Now, this is going to be attached to every instance of the cloud object. We only have one instance right now, but every time we generate a new cloud, and we can generate clouds as opposed to just dragging it up in them, they're also going to include an instance of the Cloud Controller class. Okay, just letting you know these are the way things work. Here's our cloud, and I'm going to take my cloud script and pull it into my add component area. Right now, what I want to do is what I did before. I want to take this time. What's the closest script that I have compared to my cloud? My island is pretty close. It does the same behavior. It starts at random locations on the top, and there's another behavior I'm going to add into the cloud as well. We're going to add some drift because the cloud just doesn't go up and down. It also might go this way, right? That makes sense. And it's going to be faster. It's not going to have a fixed speed. All right, we're going to make it a random speed. So sometimes clouds are going to be fast clouds, hard to avoid, and some clouds are going to be slow, even slower than the islands. So it's going to look like the island is actually the ground is going to move faster than the cloud does. And sometimes clouds kind of hang out like that. So it makes sense. It has to be from a business perspective. Whenever we make a rule, right, we're making some game rules right now. These game rules are called game mechanics, right? The mechanics of the game, how things work, right? We're creating the rules to make the game harder or easier. So right now, the cloud is going to be the challenge, right? This is the thing that's going to make it so that we are going to try and avoid the cloud with our plane. If we hit the cloud, we lose a life. If we kind of run over the island, we gain some points, right? And that's the mechanic of the game, right? Very, very simple. Okay, how are we going to accomplish this thing? So we've connected it, but we have an idea of our island controller. So first of all, let's double click on our cloud controller. So we're going to bring up MonoDevelop, or in your case, it could be Visual Studio, right? So here's our MonoDevelop. And again, I'm going to wipe out this behavior here because I already have something that's going to be pretty close to what I have. Now notice on the left, I can always choose the scripts that I already have. For example, island controllers over here. I can double click on that to open that up. And this is very close to what I need. So I'm going to kind of grab this stuff all the way up to the top, not including the name of the class. Copy it and go back into my my cloud controller and just replace the stuff that's in there. So I'm going to say paste. Now we just got to change some of these options here, right? For example, the transform is cool. We're going to keep that. This will be called cloud. The cloud sprite to the top. I'm just changing some of the things so that they're not island specific. Notice that nothing is specific. That means that we could have probably used the island controller or even the plane controller, or sorry, the ocean controller for all this stuff, more or less. It's based on the ocean controller. Everything just falls down in this game, right? All right, so from a current Y position, when we do a boundary check, top and bottom bounds to reset my cloud, I know it's going to be minus 330. So if it's less than 330, I'll put that in there. It's going to go beyond the bottom of the page. It's going to reset. And it's going to reset, as an example, to 330. That's where it's got to go, right? So 330 and minus 330. So my reset function is going to say, okay, call my reset function. So my over here where it says X position and 270, it can't be 270 anymore. My transform is going to be 330. That's going to be the top of my screen. Okay, we really didn't talk about my X position. That's the Y position. Let's think about where my X position can be. I don't want the cloud to start off screen, right? In any way, not any part of it. That means that we have a limited range for where the cloud can start off because the cloud is big, right? It's not like the other clouds. So let's do that. Let's go back into our Unity and let's test it for that. And again, when it comes to 2D games, I kind of want to bring the cloud into play and then zoom in on the cloud as much as I can within reason so I can see the borders. And I don't want to start the cloud pretty much, farther out than this. Some people might want to do this. Don't agree. Like, I mean, it's off screen. I want to start it here on screen. Now, it could be here that it starts off screen, right? Like this. But definitely not beyond the border of my game to make it so that every cloud will start off threatening the player. So if I start the cloud like this, potentially, then there's a margin of easiness for the player. He can kind of escape in some cases. So let's think about it. So for me, it looks like around 204.6. And let's go to the other side. Remember, the cloud isn't exactly evenly shaped, so we're going to see what the other side looks like. So again, it looks like about 207, you know, let's say around 207, 206. So 206 to me is probably about right. 206 and about, to me, I don't know if might be different for you, and minus 206. 206 and minus 206. That's where it's going to start off. So let's undo that change. All right, so go back to here, and we know the numbers. So minus 206, that's the range, and 206. So right now, just by doing that, we have functionality. The cloud will come down. It'll come down at the exact same speed. This is where the problem is. I like it, right, that we have a speed of 5F, but that means it's going to be the same speed as the island. I don't want to have it any too much slower than the island. And if I want to go from, let's say, 5F, so as fast as the island, maybe, I don't know, something like that, to, I want to make a range for this thing, to a maximum of, I don't know, as an example, maybe 10F. So 10, 5 to 10 pixels per frame. So 10 is fast. 10 is like twice as fast as the island. Somewhere in the middle is where it's going to hit. So between probably around 7.5 is where I'm thinking it's going to be. So pretty fast, a little bit faster than the island, sometimes as slow as an island. I don't think I want to make it any slower than that in this particular case. So I can't use a single speed for that, right? Because I need a range. So I could put a min speed and a max speed. And this is where we start changing our class a little bit, right? So I could put two values, min speed or max speed. I could do that, right? I could create my own class, right? Where I call it like, you know, with a minimum and maximum value. I could use a vector, right? Because there's a vector2 object that has two values, x and y, right? Something like that. But for me, to keep it simple, again, I'm just telling you, there's different options. You'll see it in different ways online, how they teach you how to do it. And I've done it in different ways as well. I'm going to make a min speed. I'm going to call this thing min speed. Here, it's going to be a public value, right? Minimum speed is 5, and let's say my public float max speed, as an example, is equal to 10. Why am I making him? Why am I making them public? Why do I want to expose them on the inspector? Because that's what public does, right? Why? Why would I bother? I could change it, and you know what? That's a really good thing to do, because then I can test to see, maybe I need to refine the number, because maybe it's not the right number. Maybe it's too fast, maybe it's too slow, maybe whatever. And I can fool around with that. I can't modify my script when I'm running, not directly. The only time I can modify my script is here in the inspector. So I can change values in the inspector, and that's why I make it exposed. I'm making a public value. If I don't care about exposing it on the inspector, I can make it private, and it wouldn't be exposed, right? I wouldn't see it. So now I'm going to have two values, min and max speed. Okay, cool. And let's see how it looks on the inspector. If I go back to Unity, and if I, and sometimes you have to kind of click away and click back, right? If I've done everything correctly, and if the cloud controller script is correct, well, see, I have an error. Right? Let's take a look here.
Speed.
Right? I changed one thing, but I didn't change the other thing, right? So here's this speed, doesn't know what this is, right? So I know that I'm going to go, it's going to update, and my current position, right, is going to change by this min speed to max speed. What do I need to put in there instead of min speed to max speed? Random range. I can put it right in here, in fact. Let's try that out. So I'll do that. I'll say random range. So we'll kind of do one of these, random.range. And I'll say from the minimum speed, so this dot min speed, right, to this dot max speed. Kind of simple, right? That's a very simplistic way of doing it. So I'm actually taking this random range method, and whatever comes out of this method is going to be kind of applied to this vector2 object, right? Now you might look at it and go, oh, I'm not comfortable with that. What is this doing? Shouldn't you put that into another variable? Yes, you could. You could I could extract this and make it another variable and then use that variable in here. But we're going to try and simplify eventually. So this is the first form. If you're going to see this, I'm going to do this again, by the way, in a second, right? So min speed, max speed. Yay. All right, that'll give me the vertical speed, right? Remember I talked about I want a horizontal drift that I want too, right? And we may have to talk about this drift value here in a second. Okay, and if that's true, so this min speed and max speed isn't correct, right? It's not min speed and max speed for my cloud, it's min vertical speed, right? There's also horizontal drift that I want too. So how do I change this thing, right? We have to think about that. How do I change this value so it reads properly from a human readability perspective? If we look at it on the inspector, it makes sense. How do I do that? And there's some stuff we're going to do in a second to show you this. Okay, cool. So let's go back to the inspector. And let's see if now we get this thing, if it's fixed. And yeah, we get both. We have min speed and we get a max speed. And if I run this thing now, just the way it is, 5 to 10, right, then I should get some fast clouds, right, and some really slow clouds. Let's see what the speed is. Now notice how it looks kind of the same, right? Like I don't think there's a slow cloud yet, huh?
They're fast from the ocean.
But they're all clouds. Oh, they're all fast. They're faster than the ocean, right? But I really don't know. I can't really tell that it's as slow as the island. Like I don't see anyone that's really slow, right? Some are fast, but for the most part, if I look at the scene and I pull out for a second, notice how it's just starting at a different position. Now they're definitely faster than the island for the most part, but I really can't tell. So how would I tell if I want to test to see what the actual speed is? Come on, guys. I want to test the speed. Debug.log. That's a great way of testing it, right? So I'm going to go back to my script, and in my script, what I want to do is when I've got my speed, so then after I do my reset, as an example, I'm going to get my random range. Oh man, now I know what happened. It's only going to do this. Well, it's every frame it's going to do this new vector, right? It's going to add this new vector every frame, and it's always going to be random, right? Min speed to max speed. Well, how do I figure out what my speed is? I don't know that. This is where it makes sense to pull out a variable, right? So again, I can make a local variable or some kind of private variable that kind of talks about horizontal speed, right?
What if we assign a random variable outside this, and so then it won't change the speed and everything.
Test it yourself before you suggest. Go test it out. All right, so this is what I would do. Let's make a variable, and we're going to call this, vertical speed as an example, right? So we're just going to call that vertical speed. So we'll make it a private variable, and it's going to be of a float type, right? So we'll say private float, and we'll call this vertical speed underscore vertical speed, right? Like this, and we're going to set this vertical speed up here. So every time it updates, on every update, right? Well, that doesn't make any sense. It shouldn't change my speed every update. That means every frame, it could be 5 or whatever. That doesn't make any sense at all. In fact, if anything, what we should do is we should update on reset. So every time I reset my cloud, it moves to the top of the screen, then we get a new speed for the cloud. So some clouds will be fast, some clouds will be slow. So that's where we reset the value up here. So we say, all right, this dot underscore, vertical speed as an example. And this is where we take this random range. So we're going to take this random range over here, right? Take this whole piece out, and we're going to cut it. Bear with me. And we're going to say equals to this. So some vertical speed difference. And then in here, in our current position, minus equals to new, this is where we're going to put in our vertical speed. It's going to be consistent. So this dot underscore vertical speed. Right? All we're doing is we're saying we're never going to reset the vertical speed, this value that we're going to get, until we reset. So the speed is going to remain the same the whole time. So every frame, it's going to give us the same speed, vertical speed, whatever that is, whatever that value happens to be. Okay, let's test to see how we are. And I want to also, when we set the vertical speed, I want to know what it is, right? So once we set it, I want to output this on the debug.log. I want to send it to the log so we see what it is. So this dot underscore vertical speed. Now it won't change. It'll be the same for the entire time it falls until it resets. That's what's going to happen. All right, let's go back to Unity and let's press play and let's see what we get now. So we got fast cloud, some fast clouds, and notice that the speed is down here. So now it changes. This is 8.5. This is 6.9. This is 6.4. This is 6.5. We can see that it's, that there's ones that are faster. That was a faster one. We've never gotten one that's really, there's one that was really fast. Now you can see the difference. Look, there's one that's slow, there's one that's fast, another kind of medium one, there's a medium one. Again, the average is going to be around 7.5 if you round it up, right? There's some fast ones too. Now it's working the way it should, and you can tell. No, it will approach 10, but it may get 10. It's within 10, right? Between 5 and 10. I'm getting numbers like, and if you want to see what those numbers are, you can look at the console and see that there's 9.6, 9.5, 9.9, whatever. It's very close. And the same thing with 5. It probably will get close to 5, but very rare that it'll get exactly 5. And those are the numbers. So you can see that the numbers keep changing. The speed, my vertical speed keeps changing every time it resets. And it's not a lot. It's just every time it goes down 480 pixels, once it goes up to the top, it'll reset. Okay. So this is working. This is where I want it to be. So we can get rid of that debug.log. I don't want to keep too many debug logs because what happens is it's a calculation, right? I don't want to. It's an output. Every time we output something, it slows down our game. But they're great for debugging. We want to remove them when we're not debugging anymore. Okay. I want to do the same thing with horizontal speed, right? So I have my vertical speed. Let's do the same. Another private variable. So private float, and we want to call this horizontal speed. Maybe we'll call this horizontal drift because it's not really speed. It's kind of moving around to the right and left. Okay, my horizontal drift value, right, is going to be a value between, I want you to listen to this, it's going to move to the left and it's going to move to the right. If I move to the left of the middle, what's going to happen to my sign? It's going to go negative. So it's going to go from a negative value to a positive value. That's what's going to happen. So I want to move, if I move towards the left, I'm moving in the negative, x, or the negative x position, right? And as I move to the right, I move to the positive x. So how much drift do I want? My thinking is I want it to go from -2 to +2. So not a lot of drift, just a little bit of drift to that, because it's going to move fast, right? So even a little bit of drift is going to make a huge difference depending on the speed, right? All right, so let's try this out. So we're going to say this same thing in the reset function, this dot horizontal drift, right, is going to equal to, we'll do the same thing, random.range. This is the beautiful thing about this random range method, which is built in, which is this. Now, I don't have a min and max speed anymore. I can't use a min and max speed. This is what I was telling you. How do I put in a value that I can change on the inspector? What I call it here in my min, there's min speed and max speed. And I can put, min h speed and min v speed. I can do that. Min x and min y. There's all kinds of stuff you can do, but you want to kind of understand what it does. So what I want to say is, maybe for my inspector for my horizontal, right? So, or sorry, for my vertical speed is min v speed, min vertical speed, right? Okay. If I change it here, I'm going to have that error again. So let's refactor. So I'm going to right click and I'll say refactor, rename, right? And I'll rename this thing to min v speed, right? Now you might also change this to min vert speed or something else. If I press OK, changes all the values, right? Same thing here. So refactor, rename, and we'll see how this works. We want to keep as human readable as possible. If it doesn't look good, right, we don't know what it means, then we'll change it later. Okay, cool. We can do the same thing with a couple of other float properties, right? With min h speed, right? We're going to make that -2f, right? And a public float min or max h speed, right, which is equal to 2f, right? So again, I'm kind of controlling our values here. -2f would be, drift to the left. 2f would be drift to the right, right? And we want a range like that, so it'd be the same thing. Now we just have to put those values in. So say this dot minimum h speed, right, to this dot maximum h speed, right? So minimum to maximum, and we've got our little code. I would recommend, like I said before, you do it. Don't watch me because you're not going to remember this stuff. Okay, and then what's going to happen is when we do a practical exam, I'm going to get you guys to do things in-house right there. And if you're not fast enough when you do it, it's going to mess you up, right? Because you're going to have to produce something in 2 hours, and you don't have time to watch. All right, so I saved everything. Let's see if it works. I'm going to go back to Unity, and let's see if it does what it. So there it is. There's my values. They appeared in the inspector. That's important to see. Now, you know what? I got lots of room here, so I could probably put min, and look how it split up V with H. See that? It actually, every capital, Unity is smart enough to understand that, you know, I can probably put in a longer variable in there, like minimum vertical speed. What's wrong with that, right? It's long, but who cares, right? As long as my inspector makes sense. Guys, this has got to help you or someone else you pass this off to. I'm just putting it in here so you can see what it looks like. And that's kind of crappy. I don't like it. Min V, what does mean V or mean A? I mean, you might be able to divine what it means, but why not? We have space. Let's do it. So we're going to go back here and rename again one more time. So min V, we're going to say refactor, rename. It's good practice too anyway. We're going to say minimum vertical speed. Spell, if I can spell properly. Now some people might put for minimum, you know, I'm going to take this for a second, copy it, just to be, you know, and refactor, refactor, rename, and we're going to just, you know, paste in there, and we're going to say max. Press OK, and we'll do the same thing with this one. Refactor, rename, min horizontal speed. Copy it right here. And we're going to go here, factor rename. And I'm doing this, remember, because if I do it here, I do it one time and it refactors throughout my code, right? As opposed to me going making a change. Now here's what it does to my actual code down here. It looks like it's human readable now, right? And that's what I want. I'd rather have human readable code with some variable names that are slightly longer, right? So you understand what it means. Right? So if I was going to pass this code off to you now, it kind of comments itself, right? And that's the kind of way we want to do things, not just here in Unity, but in all application programming, right? Practice. We want to make it so it's human readable. And I don't mind ever having a longer variable name if it tells me what the variable is without me having to figure it out on my own. Okay? Okay, cool. So I've saved it. Let's go back to Unity and figure out what it's going to be. Let's see if it updates. There. See, it all fits nice. Horizontal speed, vertical speed. I know what it all means. There's another way to do this to kind of you know, create little containers for it. So vertical speed, horizontal speed, and then min max. You could do that too. There's another way to do that with a different container structure. For now, this is okay. Let's see what it does. Let's press play and see what kind of effects I get. So I get one cloud, and it kind of goes down, and you see that it slows down there. But it seems to be, it's the same, right? It's just going horizontal. There's no drift at all. Well, we didn't apply it. Let's apply the speed. So we said this is our range, but we didn't really use it at all. How do I do that? Well, over here, where I did the vertical piece right here, where I said my current position, I can put in this. I want it minus equal. Look what it says minus equal to, right? Because it's going down. I got to be careful here because if I minus equals, if it's a negative value, it's going to be positive. If it's a positive value, it's going to be negative. It's going to be the same effect for us. But it's okay. It's just FYI. That's what it'll be, right? So let's put that in. So we'll say this dot underscore, you know, horizontal or horizontal drift, right? Which is what we want to put in there. So we can't do anything with it unless we have some kind of, we apply it. Yeah, we've got the value coming in here. This is the random value. But we never use the random value. We have to put it into this vector component, right? Okay, cool. So that's the piece we've made a change to. Okay, let's try this out. And let's go back and check it out and see if it works. So go back here and then run it. And now let's see if we get a bit of drift. And I'm hoping that we will. Ah, that's better. See how it drifts to the right? Now it's drifting to the right there. It's drifting to the left, drifting to the right, drifting to the left. Now why did I want to do that? Because I want it so that the clouds are quite random, right? I don't want, I mean, it's a random enemy that I can avoid, but it's going to make my life difficult. It's going to make my life challenging to pick up some, you know, some islands. I want to have 3 clouds. Remember I told you about 3 clouds. I want to have at least 3 clouds in my scene, right? 4 is too much. 4 is insane. 4 you won't be able to beat, right? The clouds are big, right? 4 clouds will take up the entire space. Even 3 clouds are going to be challenging, right? So if I was going to make a game level 1, level 2, level 3, I mean, I could make it so that level 1, you get 1 cloud. Level 2, you get 2 clouds. Level 3, you get 3 clouds. Level 4, can't save 4 clouds. It's got to be 3 clouds in a ship or something like that. Another plane coming into you to try and kill you. But that's how it could be, because more than 3 clouds when I've tested this game is too much. Okay, cool. how do I make a prefab? Because now we've got our cloud kind of the way we want it, right? And I want to make a prefab so that way when the cloud, when I want to create multiple clouds, I can just pull it into the scene from my prefabs folder. All right, to make a prefab, hint, hint, I'm going to test you on this next week, right? I'm going to grab the cloud or the object, whatever the object is, and pull it back into my prefabs folder. The folder has to be called prefabs. Notice how now my cloud turns blue. It has a different shape next to it than before, right? Prefabs allow me to reuse them, almost like blueprints, like I said. Let's get rid of this cloud in the scene now. Watch. So the cloud in the scene that I have is actually an instance of a prefab. So if I was to take this cloud instance away, right, it's gone now, right? And if I was to pull my cloud prefab back in, it would still appear at the top of my screen, okay? It's a copy, almost like every time I pull a cloud in, here's another cloud, and here's another cloud, right? Here's my 3 clouds as an example. There's 3 clouds in there, and each one of them, take a look, they're actually in the scene, right? They're just in different positions. Notice that the position, I just modified them so the position is different. It doesn't matter because when I click them to play, each one of them has an instance of the cloud controller script applied to it, which means each one of them will have their own behavior. Let's see what happens if we just do this. This isn't what we want though, okay? And the reason why we don't want this is because this is a fixed, kind of a hierarchy. This is a fixed hierarchy of what we have. And we don't want a fixed hierarchy. We want to be able to control what comes onto our scene. Because what if we have like level 1, level 2, level 3? We don't want it to be like this. I don't want to keep modifying how many are there, right? Let's click plus and see what happens. So there's 3 clouds. That's what I'm saying. This is why it's challenging now. So let's see if I was going to be able to survive. So I'm there. I'm going. I didn't get hit. Whoa! I didn't get hit. Oh, I missed it. Oh, I'm done. See, I just died. I just collided. Okay, I got 1 point. Okay, I missed it. Oh boy, what did I try and do? Right now, I'm going to try and skim out the outside. Okay, I made it through, and then oh, I probably died there because it was so close. Right? Okay, you can see what happens. So that's how challenging the game is going to be. With 3 clouds, it's enough to cause a bit of a ruckus. It's enough to cause my hazards to be really crazy, right? I can adjust that. I can say, well, you know what, if it's too crazy, maybe I can adjust my vertical speed, my max vertical speed. I can tone that down a little bit by a couple points. So make it so instead of 10, it's like 9 or 8, right? And I can make that range a sweet range, whatever that range is going to be, so it's not as nuts, right? I could also make it nuttier. Like what if I go here to my cloud, specifically for cloud, my first cloud, cloud 1, and I change my vertical speed from 10, test it, to 100, right? And see what happens. Well, there's going to be always one cloud that kind of like goes boom, right? And there's a couple, you see how it goes, right? It's just nuts, right? So a maximum of 100. So it looks like there's like a bunch of fast clouds, but it doesn't make any sense. That's like unreasonable fast, right? And actually, it looks like there's more than one cloud, but there's not. It's only one cloud resetting. Let's take a look what's happening in my scene. So my scene happens where my cloud, because it has one of the clouds has 100, it's going to go and reset a much faster rate. And chances are, because it's between 5 and 100, probably the average number I'm going to get is somewhere in the middle, which is like 50, right? Which is way too fast, right? So that ain't right. That's not right. 5 and remember, anything I change here will be reset when I stop debugging. So it doesn't matter. I can fool around. Same thing with drift. Let's make this drift crazy. So I'll say minus 10, for drift, and we'll make it 10 for drift. So it's really fast, right? And you can see how crazy. And let's reduce this from 100 to 20 because that's more like it. So we can see what it looks like. And that's only one of the clouds. One of the cloud instances are affected. The other ones are normal because each cloud is a different instance of the same cloud object. So they don't affect each other, just any other object. Let's go back to the game. So you can see that there's some clouds that are really, really fast. There's a lot more drift, like that one, like crazy cloud, right? And it's too fast. You can see that it's too fast. It's like an attack cloud. I should make it red, right? Because it's crazy attack cloud, right? But you can see that it's crazy fast, and it'll kill your ship. It'll kill your plane right away if it hits it, right? So this is cool. I've created my prefab, right? I've created my prefab, and this is a great place to stop and upload to GitHub because I've added a feature. I've added a cloud. Every time I've added a feature before, I've uploaded to GitHub. So let's do that. And I'm going to say that. I'm going to say added cloud prefab. And I'm going to get rid of some of these other clouds because I don't need them. So I don't need this one. I don't need this one. In fact, I don't need this one either. Because we're gonna make this thing generate cloud. So I've created a cloud prefab here. It's not deleting the cloud. I'm just removing the instance from the scene. So each new instance I want to make generate through code. I want to procedurally generate my clouds through code programmatically, as opposed to me dragging and dropping. That's easy to drag and drop, but in the future I want to be able to programmatically create my scene, right? As opposed to me creating it in the hierarchy over here. Okay, let's see how first let's save this to GitHub. So first, in order for me to save to GitHub, I've got to save my scene. So I'm going to say File, Save Scene. I'm going to say File, Save Project, right? So my scene and my project are all saved. All the metadata that Unity keeps track of in the background, which we can't see, is now being saved, right? Now let's close off Unity. And when I close Unity off, what happens is, right, it unlocks certain files that it keeps locked when it's open. When I'm using Unity, there's a lock that happens when it locks certain files. So we want to close those files up. This one's okay to stay open. This is just a script. So this is just I'm viewing the script. I haven't touched it. It doesn't maintain an open file. All right, cool. So now what I want to do is I want to pull up a terminal window. It doesn't matter what terminal window you kind of pull up. And I want to drag and drop my Unity project in there. So under Unity projects, and there's other ways to do that. You can also kind of navigate to it through your command prompt or whatever, or terminal. But I know that COMP305 W2016 mail pilot is the one I want to go to. So I'm going to press, even in Windows it'll work the same way, CD space, and I want to drag my folder in here like this, which will give me the path, and press enter. It'll work in Windows too. And then when I do that, I'm in there, I'm going to say git add dot to add all my files that I just changed to GitHub, or to my local Git repository, sorry. And then I'm going to kind of apply a commit. So I'm going to say git commit. This is the second step. Mine is M for message, and we're going to call this added cloud prefab, right? And what this means is I've created a, like I said, like some kind of prefabrications, where the word comes from, or blueprint, if you will. Enter. Okay, so there it is. Those are all the changes that I made to add my cloud prefab. Notice that it added the cloud controller and a bunch of meta tags, other things that are in the background we don't see. Okay, cool. Now I want to git push origin master. And what this is going to do is going to take my local repository and connect it temporarily to GitHub and force all the files up into GitHub into the cloud. Okay, let's see that. So make sure it's the same project. We'll refresh. And then notice how I added my cloud prefab shows up here. And now I have 6 commits when I'm making my project. So let's take a look at my commits. I started off with my initial commit. I added a README file. I added my ocean. I added my plane game object. I added my island game object. I added my cloud prefab. See how it's building my project? This is almost like a little manifest or a log, right, of what's happening in your project, how I'm building out my application, right? That's why we use GitHub and Git. We do this to keep track of our changes. And you can see how we're adding features every time. Okay, cool. So GitHub's all updated, and let's get back to the project. And I want to open this up again, right? So again, I would go into Unity. Here's my Unity, and then I want to open up that same project, this one again, and it reopens everything up and relocks everything down, so I can start doing. Notice that my cloud is still here. I didn't lose anything, and that's good. Okay, so before we take a break, I want to create my game controller. My game controller. And in my game controller, it's going to keep track of a couple things. It's going to keep track of collisions, right? I want my game controller to watch for collisions between objects. It's going to keep track of maybe a score. I want to see how it goes with that, right? So it's going to be like a bigger file, more complex, right? It's going to keep track of cloud generation, right? So it's going to generate my clouds for the first time. So when I start my project, my code, my game controller script, my game controller object, the empty object, is going to be added into the scene, just like every other object gets added into the scene. These objects don't get added into the scene until I click play. Once I debug, then they get added in. And when they get added in, what function, remember we talked about the event lifecycle, what method or function runs the first time? Start, right? Start triggers when the scene starts. It only triggers once, right? It's like our initialization script that runs, right? So as soon as start triggers, we're going to initialize a bunch of stuff in our game controller, right? That's what's going to happen. All right, let's check this out. So let's create a game controller. So right click, and we're going to create an empty object, because the empty object is going to be our container that we're going to use to write our script. Let's rename this empty object game controller instead of game object. Now, game controller is actually a very special object. And if you notice under a new thing we haven't seen in the inspector, there's something called tags. Take a look. Here's our tag. And what I want to do is I want to tag this empty object. I want to change the tag to say game controller. It's actually part of our hierarchy here. It's built in. Game controller. So game controller is not something that we, that's unknown to Unity. We know people have been using game controllers for a long time, right? Okay, cool. And this is a strategy, right? So if I got a game controller, and I got another one called player, by the way, right? I could put my player tag somewhere. Where would I put my player tag? Plane, right? That makes sense. I'm going to do that. I'm going to take my plane, and I'm going to tag my plane as a player. That's my player tag. Cool. Now I've got a couple new ones. I got my ocean. I don't think I want to tag that, because there's nothing I can do with my ocean. We're just flying over the ocean, right? All it does is reset all the time. What about my island? I want to do something with my island, because my island, I want to collide with my island. So it's always good to keep track of. I remember whenever I use a tag like this, it's like a name. Think about me creating almost like a name for my object, right? Not just the actual name up here, but when I tag my object, I can actually search by tag, right? If I need to. I can compare the object by tag to see if that's the object that I'm colliding with or I'm doing things with. Now I don't have an island tag, yeah? I don't have an enemy tag. So let's add a tag. Let's create a custom tag, right? And notice that the list of custom tags is empty. I'm going to create, when you click this plus button, and I'm going to name this tag island. There's my island tag, right? Let's add another one since we're up here. Cloud, right? That's a good one too, cloud. Okay, so we got our island and cloud tags, but they haven't been applied yet. Even though they're made, you still have to apply them. So let's go back to our island. And I got to see it's still untagged. I got to close, select this and go to island. I'm going to do the same thing with cloud. Uh-oh, where's my cloud? Oh, my cloud is a prefab. What have I done? I got to go down to here, cloud. And I'm going to do here, under here. Now there's a difference here I want to make you aware of when I do this. So here I'm going to kind of click this tag and say cloud. This is my prefab, right? So now all clouds are going to be called cloud, right? Every cloud that is generated from my prefab is also going to have a tag of cloud. But that's good, because that means that we can tell if I'm being hit by a cloud or an island. I can differentiate the type of object that's hitting me. Okay. On that, right, let's generate my clouds randomly. So what I want to do is I want to create, an array of clouds, right? Oh, now we're talking about an array of game objects, right? How do I talk about that? First of all, I got my game controller right here. It's called game controller. I need a script, right? So let's do that. So scripts, let's add the game controller script for my game controller, right? So right click, create a new script. This is a little bit more complicated, right? So game controller, there we go. This is a unique script. It's not going to be like the other ones. We don't have to copy anything. I do want to pull this into my game controller object. And you know what? Just to be safe, notice how the position of my game controller is off screen. It's like 207. I don't care. Let's just reset it to the middle. It won't make a difference, but for now, let's make it a 0, 0, 0. And I want to pull this game controller script onto my game controller object, right? By just dragging and dropping. Yay, this is my game controller script. This is going to fill up with stuff here in the inspector because we want to make some connections here between one thing and another, right? Okay, cool. Let's double click my game controller script and then start plotting or planning with some comments on what I want to add. So double click game controller, it's empty. So remember, I start with my initialization. This is where everything's going to start initializing. And on update, this is what's going to happen over here. Okay, here's a question for you. Do I have to control my clouds directly through my game controller script in some way? No. I never have to do that because my clouds have their own script. They're going to control themselves. My clouds are living objects. When I put them into the game, they have a mind of their own. They're going to do, because I've already programmed their mind. Their mind, their AI, is that game controller script or that cloud controller script I gave them already. Same thing with my island, same thing with my ocean, same thing with my player. Each one of them have control script, right? And once I instantiate them in my scene, right, they're independent. They run on their own, okay, unless I say otherwise. Okay, let's try this out. So I want to instantiate my 3 clouds, right, one after the other, right, but I also want to keep track of them. I want to keep track of which cloud is which, and I don't want to just instantiate random clouds or anonymous clouds. That would be bad, right, because that means I wouldn't be and I don't want to do this. I don't want to say cloud 1, cloud 2, cloud 3. That's bad too, right? So I want to be able to create a cloud array, right? This is where people get lost because people suck at arrays, okay, generally, right? Young programmers, just like yourselves, right? And no offense. I'm not trying to offend you. It's just the truth. Arrays are challenging for people to understand, especially arrays of objects that we just created. All right, so let's do this. So we're going to make it, do we want to make the cloud array public? How about this? I may want to make the cloud number public. Maybe I want to check how many clouds I want. That I want to be on the inspector. So maybe I want 2 clouds, 1 cloud. I want to test the clouds. Maybe 4 clouds is too much. We don't know, right? Let's put that in. So I'm going to put under my public instance variables here, I want to say that I want to be able to test how many clouds I have. So a cloud number, right? So I want to make this public, and it's going to be a number. I can't have 0.1 clouds. So what kind of number I need? Integer, right? Make sense? So public integer, right? And it's going to be cloud number, right? Cloud number. And I'm going to set this up. And again, there's different ways of doing this. I don't recommend, if you can avoid doing it, that you set up a value up here, right? It's bad practice, and maybe I've done it before, but we want to kind of end it off like this, cloud number. We want to set our cloud number in here, right? Because this is our initialization. In fact, what I recommend to you is even having another script that we call initialize, right? Another folder, like a method. Let's call it down here, right? So I'm going to make, and I usually want to make my own public methods or private methods underneath these 2 default methods. I leave kind of this the same. This is my own way of scripting, so I know. So I create a kind of a private method area down here, private methods, right? And these private methods down here, right? I want to call this one a private. I mean, when I make a private method, it's got to have, remember, underscore, just like I do with everything else, underscore initialize. And the reason why I want to make it a private method that I want to call initialize is because I don't want to clutter my start method with a bunch of other methods that look the same. Okay, now what does it return? It returns void. We're not going to really return anything. So it's going to be a private void initialize method with an underscore. Cool. This is where I'm going to initialize my cloud number. So I'll say this.cloud number, right, is equal to 3. We're going to initialize with a default value. Not 3f, 3 because it's an integer. Okay, cool. So that's the first place. Cloud number, it's going to be initialized here, and I want to call it in here, right? So I want to say this.underscore initialize. So I want to call my initialize method first, inside my start. Now you might say this is kind of like calling an initialize method from an initialize method, but it's okay because we're organizing ourselves. That's all we're doing, all right? So, and it actually tells you what it does. It kind of initializes my game, right? Okay, cool. What else? I need I don't know, is it going to be a private or public array? Do I really need to expose it? The question you have to ask yourself to make it, if you want to make it public or private, is, do I want to expose this variable or container on the inspector? Do you? Right? Well, the answer is I do, and I'll tell you why. I need to, how do I reference another object? I'm referencing an object from outside of my script. This is the first time we're doing that, right? So I want to make a cloud array, right? And I don't know how many clouds I want, right? So what if I was to do something like this? Public cloud array, right? Well, I can't do, look, I can't go cloud array, right? I mean, I could do a cloud array because I have a cloud, right? I want to show you this, right? Notice how if I do public cloud array, right? And I need to mention it, like call it something. So like, I don't know, clouds, right? Notice how cloud doesn't really compute. The name cloud does not exist in the current context, right? How do I do that? What is a cloud anyway? Game object. So it's a game object array, an array of game objects, but specifically a cloud, right? It's a prefab, as an example. I'm going to reference prefab. My prefab has a name, right? So I could say it's as something else, right? How do I do that, right? Game object, cloud, I don't know. Let's try this first. Let's try a game object array and see what that does. There's some good things and bad things about this, right? If I say my game object, it has to be a capital G, by the way, game object, right? So generic game object array which is called clouds, right? Save. Let's see what we get on the inspector first, all right? Because we need to make a reference to this. Notice how I'm not doing anything here in start. Okay. Go back to my inspector, and I want to see my game controller, and I've got my, whoa, look at this. I got this little arrow here, right? Clouds. And it looks like I have 0. That's weird. What does this mean? Cloud array of 0. That's weird. And the other question is, if I expose it here, my cloud array, I'd have to kind of drag and drop something. That's what it's expecting. So if I go to my cloud, and if I do one of these, look at what I can do. I can do one of these. I can't do it there. How about over here on top? Oh, wait, look. If I put my plus over my clouds itself up here, I can add it in. And I can keep doing that. I can kind of add as many of these clouds as I want. But this isn't really what I want, right? Why isn't this what I want? This is neat. It'll work, by the way. I just want to show you that it can work like this. I'm making a reference from my prefab into my script this way. It's accepting it as a game object because all the superclass of every object on the screen, everything you see on my scene, cameras, lights, anything you put is all game objects. So therefore, because it's a superclass, even the derived classes, cloud, is still a game object. It still has an is-a relationship, right? This is cool, but that means that I'm always going to have 4, man. That's not right. I want to play with the cloud number up here. How do I mess this up? How do I change this so I don't have this kind of reference? I just want a reference to one cloud. And I want to load that cloud into my cloud array, right? As an object. Any ideas? Good, right? How do I do this? Let's try this out. So let's go back. Neat, this would work, right? But this cloud array, what it does is it loads my cloud, it loads my array, it creates an array full of clouds, right? And then what I can do is I can instantiate each one of these objects. I haven't shown you that yet, but I can instantiate each one of these objects one at a time, depending on how big the array is. So I can run through a for each loop, and run through, and each time I run through it, I'm going to instantiate a cloud until there's no more clouds to instantiate, right? That would be the way I want to do it, right? So I really don't need an array exposed like this on the inspector. Nice idea, Tom, but man, I don't need it. If I don't need it, it can be private, right? Okay, let's go back. Neat idea, but I want to show you the game object array, what it would do, right? This is interesting because we're going to use this kind of notation later on. Okay, cool. I need a reference to my game object cloud. I do need a reference to one of the game objects like this. So that I do need. And I want to call it cloud. The reason why I want a game object, a reference to my game object like this, right, is because I want to be able to drag and drop and create a reference to the cloud object, the cloud prefab, right? There's many ways to do that. I could also find in my game, find by tag name, like find or by type. The other thing I want to do is, this is a game object. Do I have cloud properties? Could I look for, example, if I come here and say cloud dot, can I do something like in my cloud, because my cloud has certain properties, I want to look for that speed. Can I do like max speed? Look, I don't have access to my cloud maximum speed. How come? I'm making a cloud. Well, yeah, but I've told it game object. I haven't said cloud. So how do I get that code hinting? I want to get the code hinting to make Unity aware that not only am I getting a game object, but it's a cloud, right? How do I do that? I could do as, I could use the as keyword, right? As does a lot of stuff where it kind of, I do some kind of casting, if you will, where I can cast it as a cloud, right? I could, right? I could also just do this, and then after I get this, inside my initialize method down here, I could say something like, you know, cast it as a cloud down here somehow, right? Could. And I could do it like, say, you know, my cloud is equal to, you know, kind of get a reference to the cloud object as a cloud. I could do that, right? So I could do something like that. I could say, you know, reference to somehow make the cloud into a cloud object, right? I could, if I need to get access to its components. But how do I do that? How do I get access to this cloud object, you know, as an example, as an object, right? Because I need to kind of do that, right? Well, one thing I notice is this, right? What if I have my game object, right? My cloud controller object. And what if I made a reference to the cloud controller object and called it cloud? That might be a little different. And I would do it differently than this game object up here. Let's show you what I'm talking about here. So I would do it like one of these. I'm actually getting reference to the script. I'm not getting a reference to the cloud itself. Maybe that's possible. I want to show you these possibilities because these are options for you. All right, so I'll say game object, game controller. That's one. What about if I say cloud controller? Here's my cloud controller. So I'm going to make a cloud controller object reference to cloud, right? And it's going to be a public cloud that I want to get, right? Now, if I go to my cloud in my start and I go cloud dot, I have maximum horizontal speed, maximum vertical speed. I get all this stuff, right, in my cloud. I get access to the entire cloud object, right? But that's like my script, not my game object. I want to add I'm going to instantiate a cloud, right? Cloud. It's not a game object, but I want to get the game object, right? How about the game object? Can I do that? Can I do cloud.game object? I could do cloud.game object, right? I don't know if it really does anything. If I hover over it, what does it do for me? Right? It says public game object get this, the game object this component is attached to. That's good, right? So that's how I reference the cloud, each specific cloud, right? If I want to get to it. So this is the right thing to do. Now, I could do it by, once I save it like this, watch me now. I'm going to go back to Unity, and here in my cloud, this is all going to disappear. I'm going to get a reference to cloud, and notice that my cloud number here is 0 because, I mean, even though I've referenced it, you know, it starts off at 0 somehow. Why is that? How come my cloud number starts at 0, right? Even though in my script, I assigned it to 3. Anybody? Assigned it as 3. It says cloud number. And
Cloud number related to any object.
well, no. Cloud number is this object, right? The one I just made. And it starts off at 0, not 3. Yeah, see? And because I initialized it here, and I didn't initialize it up here, the value doesn't show. I'm telling you this is the right way to do it, but for Unity, I'm talking about C#. C# methodology, this is the right way. Unity, if you want to show it in the inspector. So let's do that again. And now what it means is I don't need my initialize method just yet. I will use it, but let's do this. So cloud number is equal to 3, right? As a default, get rid of this. Leave my initialize method there, even if it's empty. I want to use it as a container, all right? Now my next method, my next trick, right? In my initialize method, I want to instantiate my clouds, right? I have a reference to my cloud object. How do I get that? Well, I have to do it in the inspector. This is the trick. This is where we use the inspector a little bit more. So I take my cloud prefab, right? Now watch, and if I drag it into this, it highlights blue. If it highlights blue, we're golden. Notice how I get a cloud, and it doesn't actually look at the cloud itself. It looks at the cloud controller. That's going to point to its object here. Hey, how come I'm not getting my cloud number? My cloud number is still 0. What's going on? Why? Why is my cloud number 0? But over here in my script, right? My cloud number is 3. I made it 3. I said it was 3, right? I'm not getting 3. How come? Let's go back. Huh?
Select the different operations.
It's not that cloud.
What do you mean? I say cloud number.
It is cloud space.
No, it's the same one. That's just the way Unity looks at it, right? What was that? I did save my script, but let me go back to this. See? Look, I've got my clip. Oh, this one, yeah, I did save this one. If I didn't save it, then it wouldn't show up like this. If I make a change to my Unity script here in monodevelop as an example, right? You know, and this is my initialize, I say initialize method, right? I can tell that it's not saved, right? When I save my script, if I press C on the right hand corner here, how it's a bubble. If I click save, it becomes an X. See that? That's a subtle change that you can tell it's saved. So this is saved now. So cloud number 3 is here, and then but I don't see the change happening in my script, which means there's two possibilities. One, there's an error somewhere, right? That's one possibility. Usually it doesn't show stuff unless there's a problem, like cloud number 3. So it's not showing up. Okay, number 1. What about if I just set it now? Will it remember, or will it be gone? And if that's true, if it sets it to 3, and if I go back down here and I move, but this should set to 3. What if I set this to 30, for God's sake? So 30. I save it, it's public, it's an integer cloud number, right? And I told it what it is, right? I've assigned it 30. And if I go back to my script, to my Unity, well, I got 3 there. What if I erase it? Yeah. Reset it to 0, or just get rid of it, there it is, and I go back and forward, and then I don't see anything.
So reset it.
Reset what?
Reset the controller.
Here?
Yeah.
Let's see. And I'm showing you this because what's happened is somewhere along the line I typed a value in there, right? Just to let you know, so that way you can see. If it's reset, I lose the reference to the cloud object, so I have to make that reference again. I have to make that connection. So here's my connection, look. I made it from the prefab into the game controller. If I don't do this, no connection. Okay? Cool. So I've got my connection in here. I've got 30 clouds. That's whack, right? So I'm going to put that back. Instead of 30, it's going to go down to 3. And if that's true, then maybe, right? Maybe I can go back down here and put that in there. So I'll say this dot underscore or dot cloud number, right? Maybe that one will go to 3 if I reset it again. Let's check this out and see if it's true. Right? So go back. Oh man, what happened?
That method will execute when the game is run, right?
Well, man, what happened? Come on.
That method will execute when game will run.
Well, all I'm saying is I want to show you so you've seen it, right? Because you may think that this is going to do it, and then you're going to bounce your brains around trying to figure it out, right? But the reality is that it's got to happen up here, right? Just to show you that clearly that's what it is, right? So let's get rid of this. And every version of Unity is slightly different, right? So if I save it, I go back up to Unity, right? Notice that the value is not changed yet. I got to reset again because I've monkeyed with this thing. Once I monkey with this thing, I've got to go back and reset it. And it's never going to be the same until I add a new controller. Okay, cool. So I've got 3 clouds. I want to run through my cloud. There's no cloud count. I don't need to do a cloud count. All I have to do is I have to do a for loop with the cloud number. And however many clouds I put in, I want to instantiate my clouds. Okay, let's show you how to do that now. And I'm going to do that where? In the initialize method. I could also do it in other places as well. But let's just do it there. So here in my initialize method, I'm going to say, here my for, and again, I remember how this works out, right? So it's going to be an integer, and it's going to be a cloud, right? And my cloud, or number of clouds, cloud num, whatever it is, or index, number, whatever you want to call it, count, cloud count. For a cloud count, right, is equal to 0, right? Where cloud count is less than, this dot underscore cloud or this dot cloud number, right, which we already stated, right? Then cloud count plus plus, which is going to increment the number of clouds that we have in play, right? And then notice how, as a best practice, always use curly braces after your control statement. We don't want to do it, even if it will run in C#, you don't want to run it in C# like that. Then we're going to use the instantiate keyword. Instantiate, that's new. That's part of Unity. Instantiate, and then we talk about the object. Well, we want to instantiate a new object, which is a cloud, right? and I want to make a copy. It's a prefab that I want to use, right? And I've got a cloud controller. We got a cloud itself, right? That I got right here, an instance of the cloud object, right? So could I do something like this? Cloud, right? Dot game object. Could I do that? Would that be enough? Or do I have to put the new keyword in there? Right? Well, I don't have to use the new keyword. The new keyword is inside my instantiate. All right, just letting you know how it works. So I want to use this cloud, the game object that's associated with the cloud component, the cloud controller component. All right. I know this is a little bit roundabout method, but let's take a look and see what it does. So first, let's go back to Unity. Do we have an error? Right? No. If the error would pop up right here or in the console right away. You'd have an error in here when it compiles. Let's run this puppy. Notice that there's no clouds inside my hierarchy. And run. If it fails, it'll fail now. Now notice what I have. I have 3 cloud clones, right? 1, 2, 3, right? And what happens is they instantiate one time, right? And now they're going to add in, and they have their own behavior that's associated with them because of my game controller. So I'm actually using my game controller script to access a script that's outside of itself. This is where people go like, what the hell did he just do? I don't get it. It's not normal C#. No, it's not. It's the Unity API you're learning, people. Right? So you're not learning C#. Right? If you've never done C# before, don't worry about it. You're learning about the Unity API. The Unity API works just like this. You have to make a reference to the object by dragging and dropping from the prefab into a container that we've exposed inside the inspector. Right? If we don't expose some kind of reference object, this container object, we cannot make the connection so easily. There are ways of doing it programmatically without exposing something on the inspector, but it's more challenging. It's more challenging, right? This is the easiest way. Clear? So we have our game controller, the first version of our game controller, and all it does is instantiate 3 clouds. Let's check it and see if we can instantiate more. So here's my cloud number. Can I change it in-house? Like, can I go 10 right now? Will that do it? Well, no. Because remember this, the cloud number only functions in the start. So I even if I make a change there, it doesn't matter. It's really here that's important. If I make this 4 to change it, to test it, and if I run it now, I can see that now there's going to be 4 clones, right? And see how they don't go away. They always stay the same amount. Even though it looks like there's a bunch of clouds happening here. There's really only 4 clouds that get recycled every time they leave the screen. They go back to the top. This is a great way of maintaining memory, right, in a game. I'm not going to instantiate more objects in gameplay. I'm just recycling the objects that I have in game. So it makes a very stable environment. If I was to instantiate new objects every time they left the screen, that's an option too, by the way. So I reset. When I reset, I don't reset. I instantiate something new, and I destroy something else. So I can have a destroy. There's a destroy method too. So I can destroy an object, and I can create and instantiate an object. Destroying and instantiating objects take a lot of cycles. All right, they take a lot more. There's more operational cost to them, right? When we instantiate objects, we only try to instantiate objects one time at the beginning of when the game scene loads. Then all the game scene objects load, we have everything in play, and then we can use them. We can bring them on into our view. Sometimes objects will exist as this is a strategy for game creation. Okay, it's all around tricks for games, right? Objects will exist in the world, but not available in our view. So here's what we see in our view, everything that's in here, right? But objects might be, I might have another 1,000 objects that have been instantiated off screen. And I only want to bring them in when I need them. But I don't want to recreate them, again, right? And the reason for that is speed. As soon as I create my objects, they're ready for me to go. Any questions around this? So there's a couple of issues here that we talked about, just as a recap before we break. 1, we talked about how we can instantiate prefabs, right? We created a prefab last time, right? We created our island or our cloud prefab, and now we've created our first version of our game controller that accesses the cloud prefab, right, through its script, because the script is available. We can actually search for the script. It's part of our. So think about almost all the game scripts are part of the same namespace, right? So our game controller class, right? We're accessing the game controller class, and it's attached to a game object, because the game controller class is a component of an existing game object. Our game object happens to be a prefab that we've created, right? And that's how I was able to backwards, traverse what I'm looking at. So here's what I'm looking at. I'm looking at the cloud, but I'm looking at the game object that the cloud belongs to. And the cloud isn't really a cloud. I've just named it cloud. It's really the cloud, an instance of the cloud controller class, right? So that's how you do it. Okay, and it's a very simple way of instantiating objects from other classes. Let's take a short break. When we get back, we got to start talking about collisions, which is a whole new thing we have to talk about. And it makes it very challenging for us to create collisions between two sprites. Okay,